So what is wormhole?
A wormhole. Okay. So let's say I have a paper. Okay. Let
Okay.
me give you an example of a paper basic. Uh, let's say I have this paper in my hand. Okay. This is my book,
Okay.
Alphabets for Non-Mathematicians. I'm using paper of it. I'm not. Yeah. So if you want to go from here to here,
Hmm.
you will go straight way. Okay. The
Yeah.
shortest possible way is a straight way, straight
Straight.
path. You will not go
Okay.
like this. You will not go like this. You will not go like this.
Hmm.
The shortest possible path from point A to point B is a straight line.
Yeah.
But what if you say that I want a path which is even shorter than that? Then
Okay.
we have that wormhole theory. That if we just have a paper like this, okay, figure out like point
Hmm.
A to point B, then you just do one thing. Just fold the paper like this, and you even now you have an even shorter path,
Sort.
much shorter path than just traveling straight from A to B. Now you have a much shorter path than that. So that's basically a wormhole. So let's say, for example, right now you are in Delhi. Right now I'm
Yeah.
in Mumbai.
Mumbai.
So instead of flying straight away to you, I will create a wormhole. This is Delhi. This is Mumbai. If I
Hmm.
create a wormhole, I just and wormhole works like this. Works like this. So I just travel that distance. I mean, even faster than an airplane or faster than anything present here that
First.
human has created. So just joining a
Oh.
far away distances by folding the space time. It's a complex stuff. Not, I mean, very beginner people can't understand it maybe, but it's a complex stuff. You need to understand of space time about it. This is space time. So if you just go from A to B, just you can create a shortcut by just bending the space time,
Shortcut.
and you now have a much shorter path. And that shorter path is like a hole or some, it's like a tunnel. It's like a tunnel, and that tunnel is basically a wormhole. It has two mouths. Yeah. In Interstellar movie,
So
there is a mentioning of a wormhole, if you know. Yeah,
yeah,
have you seen Interstellar?
Interstellar. Yeah, yeah, yeah. Many times.
Yeah, yeah, yeah. So they actually traveled a distance from Saturn to the Gargantua system, like within a very short amount of time, and that was due to there was a shortcut. There, it was instead of traveling straight, they actually created a shortcut, and through that shortcut, they could actually travel such a huge distance within a very short amount of time.
Short amount of
Yeah,
time.
so that's what a wormhole does. You know what? It
So
not only joins
no.
it not only joins places, it also joins time.
Hmm.
You can even time traveling with a wormhole.
Time travel possible in wormhole.
Yeah, exactly. It is possible. So that's the thing about wormholes.
Uh, can you elaborate?
So let's say sp-
Yeah.
Einstein said, this is what Einstein said, that time is just like space. Okay,
Okay.
just like space. What is space? It's
Hmm.
just like place. Like for example, the space. Okay, so let's say your location in space is Delhi. Your location, my location in space is Mumbai. But as I
Okay.
said, time is just as space. All right.
Space.
So if I say you that a 15-year-old is also a point in space, so you can travel to your 15-year-old self, right? So
Right.
wormhole can also connect. What wormhole does? It connects two points in space, but time is also a space, right? So you can even connect 2 points in time. So you can connect right now your timeline to the 15-year-old yourself, and now you have a time travel bridge, and you can actually meet your 15-year-old self if we create a wormhole that actually joins the time, two
Okay.
positions in time that we can do.
Okay. So just imagine if I fell into a black hole.
Sorry.
Just imagine if I fell into a black hole.
Okay.
So what will actually happen to me second by second?
Second by second. Okay. So there is a black hole. That depends. If you have a small black hole, there are two black
Hmm.
holes. Okay. There's a small black hole. There's
Okay.
a huge black hole. And if you fall into a stellar mass black hole, a black hole which is
Hmm.
made by a star, okay, We'll discuss about that later, but let's first discuss how it feels like. Okay,
Okay.
we'll discuss about it later words about how a black hole is formed from a star. But let's now discuss about uh, how it feels like. Okay, so
Feels
let's say you
like.
have a small black hole. Now, falling into a small black hole is, it hurts so much. It will hurt so much because the smaller the black hole is, look, when you start going closer to a black hole, now what happens if you go even close to a black hole? Then this is you, okay? So the force
Okay.
on your feet will be much greater than the force on your head. So it creates that stretching effect.
Oh.
Yeah, the same stretching effect is what the Earth has over the moon. You know why the moon is always faced like on one? Why does moon face only one face on towards the Earth, not the other? Have you ever seen the opposite face of the moon? No one has.
No, no, no.
No one has, because the moon is always facing like one. Is only facing like it has this like same face all the time because
Same.
it's what you call uh it's like tidal lock. The moon is tidally locked because the far side of the moon is less attracted by the Earth's gravity than the nearer side.
Near
The
side.
nearer side always remains locked throughout. So the only side the moon you watch is the basically the famous side of the moon, which we all know. So you never see the opposite side of the moon. The same thing happens near a black hole. The force of gravity on your feet is much more than the force of gravity on your over your head.
Hmm.
So it's like a stretching effect. And the nearer you go to a black hole, it will stretch further, stretch further. It will spud you. It will spud. It will. Sorry, there's a word for it. Okay, it will spaghettify you.